Hello, my lovely viewers. Welcome again to Mathematics and I. It is your favorite presenter, Jeff Naino, and today we are still on the topic circle geometry. In this video, I will be teaching how you can solve problems involving circle geometry theorem 2. If this is the first time joining us, you are welcome to our channel, but please don't forget to subscribe and also don't forget to share our videos so it can get to those that really needs them. The theorem for today, which is theorem 2, says angle at the center of a circle is twice the angle at the circumference. Now, what we are going to be learning in this video is 1. I will be teaching how to show that angle at the center is actually twice the angle at the circumference. And after this, we shall be solving an example before we come to the end of the class. So sit back, relax, and listen. First of all, let us prove or let us show how actually angle at the center is twice the angle at the circumference. Okay, like say this is a circle, okay, and let us say this is the center of the circle. Now, if I should draw a line from the center, it is actually a radius. And if I draw another line, it is also a radius because both are drawn from the center of the circle. Then if I should draw a chord from the circumference to this point, and then I draw another chord from the circumference to this point. Now, if we say the angle here is theta, according to the theorem, it means the angle here will be 2 theta because the theorem said the angle at the center is twice the angle at the circumference. So, if the angle at the circumference is theta, it means the angle at the center would be 2 times theta according to the theorem. So now, we want to prove how this is possible. So stay put. Now let us draw another diagram by introducing a third line. For instance, we have A, B, C, and then we have the center as point O. Now, if we should divide this angle at the circumference, which is angle B, which is theta, if we should divide this, to a point D, this is what we're going to get. Let us draw another diagram so that it will be clearer. Now, if I should divide theta, let us say we divide theta into 2, theta 1 and theta 2. So it means theta is equal to theta 1 plus theta 2 because we have divided theta. So if we add these 2 theta, we're going to get the original angle at the circumference, which is theta. Okay, let us take another diagram. Now, if this is the center, and this is a radius, and this is now a radius, and like we said, this is a chord, and this is also a chord, and then we said we introduced the third line, and we said here is A, B, C, and this is center O, and this is point D. And now, according to our definition here, the angle here is theta 1, and the angle here is theta 2. Alright, now we are looking for this angle. How this place is 2 theta, so we're not going to put anything here yet. Okay, let's proceed. Now, you would know that in this diagram, angle ABO is equal to angle BAO, which is theta 1. Now, how come the angle here is equal to the angle here? I would explain. Now, don't forget that the line AO, line AO is equal to line BO. Now, how is line AO equal to BO? It is very simple, because line AO is a radius and also line BO is also a radius, and radius are equal to each other. So because BO is equal to AO, it means the angles of B and A, which is called the base of an isosceles triangle, are equal. So if here is theta 1, here becomes also theta 1. Base of an isosceles triangles are equal. Now, also, angle CBO is equal to angle BCO, which is equal to theta 2. Again, how come? Why? Line CO is equal to line BO. Because again, both of the lines CO and BO are radius. So because both of them are radius, it means they are the same. So it means BOC as a triangle is an isosceles triangle. And in an isosceles triangle, the base of the angles are equal. So angle B here, okay, is equal to the angle also here, angle C. Are you with me? Now, let us proceed. It means that if I should draw another diagram, as this is the center, the radius, a chord, also a chord, okay, and then we introduce this, and here is A, point B, point C, point D, and point O. Now, according to our illustration, here is theta 1, here is theta 2, again, here is also theta 2, according to what we said here, and also here is also equal to theta 1. Right. Now, this is what we're going to do. Next, we are going to look for this angle here, which is angle COD, and this angle here, which is angle AOD. That is the next angle we want to look for. And how do we get that? Let's proceed. Okay, now for us to be able to get angle COD, now angle COD is equal to theta 2 plus theta 2, which is equal to 2 theta 2. Now the question is, how did I do that? Now watch. The angle here is an exterior angle of this triangle, BOC. So according to this law, which says the exterior angle of a triangle is equal to the sum of the opposite interior angles. So if here is 40 and here is 30, and we are told to look for x, it means x is equal to 40 plus 30, because the theorem says the exterior angle of a triangle is equal to the sum of the opposite interior angles. So if we should come here now, this angle here, COD, this angle here, is the exterior angle of triangle BOC. And the opposite interior angles are theta 2 and theta 2. So what does that mean? It means we are going to add them together to get 2 theta 2. Next, let us look for our angle AOD, which is this angle here. Now, angle AOD is equal to, now angle AOD is the exterior angle of triangle AOB, the triangle here. And the two opposite interior angles are theta 1 and theta 1. So it means angle AOD becomes the sum of theta 1 plus theta 1, which gives us 2 theta 1. So if I should draw, the reason why I am drawing different diagrams is for us to illustrate what we are doing. Now, if I should draw another diagram again, okay, center of the circle, okay, radius, now we have a chord, and we also have a chord, and then we have this, and then we have A, B, C, D, and O. Now watch. Here, according to the diagram, is angle theta 1. Here is angle theta 2. Here is also angle theta 2. Here is also angle theta 1. Okay, now what do we have here now? Here, which is angle COD, was 2 theta 2. And here, which is angle AOD, was 2 theta 1. Now, let us compare. Watch. According to the theorem, if you take a look at the angle at the circumference, which is theta 1 and theta 2, and if you take the angle at the center, which is 2 theta 1 and 2 theta 2. Now, for us, you coming? Now, if we should add the angles at the center now, which is 2 theta 1 plus 2 theta 2, we are going to get this 2 into the bracket of theta 1 plus theta 2. And how did I get this? I factorized 2 theta 1 and 2 theta 2. What do they have in common? They have 2 in common, so that's why I factorized out 2. And then I'm left with theta 1 plus theta 2. But don't forget from the beginning of the class that we said theta 1 plus theta 2 is equal to theta. That was the beginning. So therefore, what do we have here? 2 theta. So it means that the angle at the angle at the center of the circle is twice the angle at the circle, because the angle at the circumference here now is theta 1 plus theta 2. Are you there? And it is 2 times theta 1 plus theta 2, which is the theorem we are discussing today. So class, you see how you can show that actually the angle at the center of a circle is twice the angle at the circumference. Now this is the proof. Now after this, the next we are going to look is how can we use this now in solving problems. I'll give just 2 examples, and with these 2 examples we come to the end of today's class. Now example number 1. Example number 1. All right. Okay. It says find x. Find x in the diagram below. Now this is the diagram, a circle, and then we have center at the point, we have the radius, we have also the radius, then we have a chord, and also we have a chord, okay, and then we have x, and then here we have 30 degrees. We have A, B, C, and then center O. Now we are told to find the value of x in this question. It is as simple as that. What theorem are we applying? The theorem for today, which says the angle at the center of a circle is twice the angle at the circumference. So if we should follow out that theorem, what is the angle at the center of the circle? 30 degrees. Now, is equal to twice. Now, twice simply means 2 times. Now, the angle at the circumference. Now, what is the angle at the circumference here? X. Are you with me? So here becomes 30 degrees is equal to 2x. And of course, if we are looking for the value of x, it means x has to be the subject of the formula. So for x to stand alone, we have to divide both sides by 2. So if we should divide both sides by 2, now when 2 should cancel out 2, what do I have here? X becomes 30 divided by 2 gives us 15 degrees. That is the answer to question number 1. X is 15 degrees. Okay, so now let us take another question. Example 2. All right. Now, example 2 says. Now, example 2 says also find x in the diagram below. Let's take another diagram. Now, if this is the center, we have a radius. We also have a radius. We have a chord. We also have a chord. Now, if we should have 60 degrees here, and then we have x here. Now we have A, B, C, and O at the center. And then we are told to find the value of x. The same thing applies. Now, the angle at the center now is x, which is equal to 2 times the angle at the circumference. And what is the angle at the circumference here? 60. Alright, and 2 times 60 of course gives us 120. So x becomes 120 degrees. That is the value of x. So question number 2. So you see, this is how you can solve problems on circle geometry theorem 2, which has to do with the relationship between angles at the center and angles at the circumference. So class, we have come to the end of today's episode, and I hope you enjoyed yourself, and I hope you've learned something new. If this is your first time joining us, please don't forget to subscribe. Don't forget to put on your notification button so you always be among the first to get notified when a video is being uploaded. Till we meet again in our next class, I want to say thank you for watching, and don't forget to follow us on Facebook, Mathematics Bolster, and also we are also in TikTok, Math Not Hot. Thank you again for watching, and bye for now.